Hi everyone and welcome back to Internet Report's Pulse Update, the bi-weekly podcast where we discuss what's up, what's down, what's working and not working, and generally keep our finger on the pulse of how the internet is holding up week over week. This week we're chatting about navigating those pesky edge cases that pop up from time to time and looking at an availability issue at GitLab caused by change requests, a perfect storm that resulted in a capacity issue for Microsoft Azure, and what appeared to be a localized availability issue for a number of meta services like Facebook, WhatsApp, Instagram and Threads. Let's start with the download, my TLDR summary of what to know about the internet this week in 2 minutes or less. In recent weeks, we saw multiple examples of key services being impacted by disruptions that appear to be caused by unexpected outlier scenarios. With the architecture of platforms and environments as complex as they are today, enterprises and governments have made concerted efforts to scenario test as many eventualities as possible, with the express intent of being prepared should something happen. But the reality is not every contingency can be planned for, which is why having robust visibility is important so you can recognise when something unexpectedly goes wrong, pinpoint the root cause, and action remediation or fix. Good visibility creates a window of time where a provider may be able to route around an issue to minimise the impact, or where a customer may be able to switch over to a backup or an alternative platform to maintain business continuity. We saw 3 potentially outlier-related events play out recently at GitLab, Microsoft Azure and Meta. Edge cases as well as extended timelines were a factor in both the GitLab and Azure incidents. A reported delay in deploying an infrastructure as code change at GitLab, and extreme caution that may have led to a longer time frame when rectifying a capacity issue at Microsoft Azure. In both cases, it had unanticipated customer-facing consequences. We're going to chat more about that later, and these outlier scenarios that led to these disruptions later in the podcast. We also saw a third potentially outlier-related disruption of Meta on July the 10th. During the outage, some of the users had issues accessing all of Meta's platforms, including Facebook, WhatsApp, Instagram, and its newest arrival, Threads. From ThousandEyes observations, the impact of the July 10 degradation appeared to be localized to the northeast United States, although there were reports of access issues broader afield. While Meta hasn't released an official explanation, the incident appeared to coincide with severe weather in the region, and it's theoretically possible that Meta had a weather-related issue, though this is purely speculative on our part. Severe weather events represent another edge case scenario that's hard to plan for. While companies know that bad weather may happen and that it can impact their data centers, it's impossible to anticipate all weather events and when they'll occur. Good visibility and thoughtful backup plans are important to help your company minimize the impact of unexpected weather events. As always, we've included chapter links in the description box below so you can skip ahead to sections that are most interesting to you. And if you haven't subscribed yet, we'd love you to take a minute to hit subscribe button now. It really helps us out and also makes sure that you're the first to know when a new episode drops. And please feel free to email us anytime at internetreport@thousandeyes.com. We always welcome your feedback and question. And now let's take a look at the overall outage trends we've been seeing. And to help me take a look through all of this, I'd like to introduce Brian Tobia. Nice to have you again, Brian.
Thanks, Mike. Glad to be back. Appreciate it.
Great stuff, mate. And now let's take a look at the overall outage trends we've been seeing. Global outage numbers initially dropped, decreasing from 148 to 117, which is a 21% decrease when compared to June 26th to July the 2nd. This was followed by an increase with global outages rising from 117 to 192, which is a 64% increase compared to the previous week. This pattern was reflected in the US, where outages initially dropped from 65 to 61, which is a 6% decrease when compared to June 26th and July 2nd. The US outage numbers then rose from 61 to 96 the next week, which is a 57% increase. So US-centric outages accounted for 51% of all observed outages from July 3rd to 16th, which is larger than the percentage observed between June 19 and July 2nd, where they only accounted for 41% of observed outages. This actually continues the trend of observed outages since April, in which US-centric outages have accounted for at least 40%, but only the second time this year when it's exceeded 50% of all observed outages. So when I look at these numbers, that 64% increase in global outages stands out to me. What's causing global outages to more than double in that 1 week period? To investigate this, I looked at North America, EMEA and APJC individually. And what I saw was that both North America and EMEA have increased in comparison to previous weeks, which is 57% and 38% respectively, while APJC outages actually decreased by 28%. So it appears that the increased outages in North America were largely responsible for the increase in global numbers. However, when you look at the outages themselves, most of them appear to be fairly brief and happen outside of business hours. So the customer impact was likely to be minimal. Even though we're seeing an increase in outages, the overall impact remains pretty low, which is good to see, though more significant outage events really definitely do occur and they still do happen. Now let's discuss some of the outages from the last few weeks as we go under the hood. On July 5th, Azure users in Western Europe experienced packet drops, timeouts, and or elevated latency over an 8.5 hour period, which was between 7:22 UTC to 1600 UTC. The cause was ostensibly a fibre cut caused by severe weather conditions in the Netherlands. Ordinarily, it appears that a load would have been redistributed over the remaining fibre, but in the Netherlands that evening, and in outage land more generally, when it rains, it pours. It appears that the links were already operating at peak utilisation due to another incident that happened a few weeks before, when the links were incorrectly thought to have been active when provisioned. As a result, the planned upgrade was approached cautiously to ensure that when the new links were next added, they were in fact online, i.e. they wouldn't add in non-active links to the system. As a result, the already stretched system then became flooded when faced with the storm damage to the fibre. So Brian, would you like to take us through what we saw through the ThousandEyes lens?
Yeah, absolutely. I think this is a really interesting one to take a look at. For all those listening on the audio-only podcast, we're looking here at a screen. It's a view of the path visualization from ThousandEyes. So we'll talk through it so you get the details as well. And for those who aren't familiar, ThousandEyes is a platform that gives you a great view into the entire digital supply chain. We have agents across the internet providing multiple vantage points. As you'll see here, we can test performance between different cloud providers and different geolocations. So what we're looking at is a share link. We do some normal testing between some of the availability zones within the cloud providers. So as Mike was mentioning with the Azure region, we were looking at the inter-AZ performance, and you can see we're currently seeing some latency here. You can see a latency of 226 milliseconds, and then for our specific location here within the West Azure AZ.
What we're actually looking at here is we're going back to that June the 16th period. So we're actually looking at there when we actually sort of this first disruption saw, because this is a precursor, essentially, the thing that that led to the perfect storm when we had the storm that then sort of caused these delays to occur.
Yeah, exactly. And this is when the links were trying to be brought online, and then they actually saw that increase in latency due to the failure in the automation system. So that's exactly it. So it's interesting to see the latency there. And then there's some packet loss associated with it as well. So you can actually see some increased packet loss around that same time. So again, both of those very related to the original kind of catalyst to the outage that occurred this month. This was kind of the precursor to it.
Yeah, and if you just go back to latency there, let's just take this in context, because obviously loss rate, we can see it's lost there. But we're looking at the loss rate there, and people might be looking at the screen, and for those of you listening to the audio version, we're sort of talking sort of low milliseconds, and we jump up to, I think it's around 250 milliseconds there. My old eyes can't quite see on the screen there. But in the scheme of things, that might not seem bad, but we're talking about inter-AZ traffic here. And if you look and if you go to our cloud performance report, you'll see our average is normally around 2 milliseconds or lower. So what we're looking at here is a huge increase. And then if you then multiply that up, we're starting to see these backwards and forwards of conversations or traffic being transitioned between the two. That obviously builds up. You know, back into my old days talking about application turns. Each one, if we do these, one of these represents an application turn. I have to add that to each one of these transactions or these application turns as it be.
Yeah, it's a great point. I mean, because like you said, like the normal baseline for within a cloud provider, it's very low latency. So this would almost be like a consumer latency being like in like a 1 second range. Like that's the kind of impact that it's actually having. The number doesn't seem huge, but compared to what it normally is on their backbone within that provider, it's a lot bigger than the number might actually tell you.
Excellent.
All right, now let's shift over to a share link that we're looking at for the July outage here. Again, same test, so inter-AZ performance test on the West Europe region within Azure, but now we're actually looking at it from the July 5th date, which is the outage that we were discussing before. And the interesting part here is you can see beforehand what that latency was. So we were just saying how low that latency normally is. So you can see right here, it's at 2 milliseconds, right? So that's kind of baseline normal. And then when we saw that jump before, right, that's what really triggered it, to show us that there really was a problem. And same thing here. So in the timeline, if we scroll ahead a little bit, you can actually see the latency jumps up to 86 milliseconds. And this is, again, indicative of that problem. And we were talking in this case where the load balancing was should be kicking in and should be, dealing with the failure there. But since those links weren't active, now's when we hit that perfect storm. And now we're seeing those latencies come up again.
Exactly. And so just to sort of bit of background here, there's four, in this particular case, there's Microsoft tells us there's four major paths. And what happened? Perfect storm, rain. So we're already running at high utilization because when we'd had that June 15th incident there, when the links weren't able to get in, as you said, the load balancer tried to redistribute load. It was redistributing load to links that effectively weren't active. So therefore, then we're causing loss rate, which is what you showed us in the last share link there. Then what happened there? So now we're running on this link. They'd quite rightly gone forward cautiously. So we said, what we're going to do is we're going to sort of wait our time. We're going to make sure that we check so that when we bring this stuff back onto the automated system, everything's really good. So the added capacity wasn't there. So now we've got these four links between hand. That's all we've got. The storm, quite severe storm, came through and actually cut one of the fibers. So we're now down 25%. So we're already running high, and now we're only down to these three links. Even if we did try to write for that imbalance, we sort of it's caught into a pint pot. The traffic's just going to flow over the top, which is what you're showing us here.
Yeah, exactly. And I think this really underscores the importance of actually, I think we rely a lot on automation. We assume that we have load balancers in place, and, if something fails, we're good because it's going to fail over. We've set that up. But, this really shows the importance of actually A, testing, and B, making sure that what's sitting behind that load balancer, right? It's not magic. There has to be resources there for it to actually be able to load balance. So I think the interesting part of this was that the assumption was kind of made that everything on the back end was working, but you need to verify those links, verify the capacity is actually there so that, when a situation happens where we actually have to leverage this in a real world production use case, that it can fail over for that. And I think that's definitely a lesson here we can learn.
Yeah, absolutely. And, again, to sort of back up there, they'd actually taken steps, they've realised they were trying to use capacity, but just these two things coinciding, and you can't actually plan for that. But you've actually said there was an interesting point there. You said sort of, rely on the automation, and that is actually a perfect segue into our next outage, which was a GitLab outage. So in this outage there, it was caused by another unexpected edge case, or what we believe to be unexpected edge case from there. On July the 7th, users of the popular DevOps platform GitLab experienced nearly 4 hours of disruption where they encountered sort of 503 service unavailable errors when interacting with the site. The root cause of the site-wide outage was a result of a stale, outdated Terraform pipeline, and we'll get to that in a minute from there. But as part of a change request, an old pipeline was triggered, and this applied an obsolete Terraform plan to the production environment. GitLab had actually told us in a post-interim report. So before we actually get into this outage, Brian, do you want to just describe, because, and I quite often interchange GitHub and GitLab incorrectly, but just want to just sort of tell us the difference between the two?
Yeah, sure. I do the same thing. So GitHub is, obviously the platform itself, but you can be integrated with other CI/CD pipeline tools, but you integration to yourself, whereas GitLab has that built in. So it has the whole pipeline built into the tool itself. So it kind of end-to-end automation there, after you check in the code, those are already built in. So that's kind of the key difference between the two.
And that's actually good, because that's the important part. The fact then we're talking about that CI/CD pipeline from there, and then this was sort of the basis of it. So you talked about in the previous outage, we talked about the automation system sort of being there or wanting to be available. What happened here was we actually seemed to switch to a stale pipeline. So what do we mean by that? What when we talk about a stale pipeline? I mean, obviously the name's in the word there, but what were the implications of having a stale pipeline, I guess?
Yeah, so if you think about pipelines and different like snapshots of them, right? The whatever is your current one is the one that's being worked on, and also is what's deployed out. So what's meant by a stale pipeline is that an older version was actually made as the active one. So there were changes in place on production system on whatever version that was running, but then when the stale one was introduced, it all of a sudden it brought into play that now whatever resources were deployed probably didn't match that state because there had been changes since that stale one was actually, snapshotted between that time and what was actually in production.
Got it. So when we switch over, we switch into something, as you said, that's stale. It's like mine.
Yeah, exactly.
When I deal with the bread, I just toast it. So we obviously couldn't do that from here. The post-incident report indicated the outage scenario was an outlier, right? So they did a very good outage or post-incident report on this. But the fact then this was an outlier was actually a reminder to us that it's impossible to thoroughly plan for every possible eventuality that might materialise. They go through and they say the same action was performed multiple times without it causing any issues. They, to your point earlier, they'd have actually thought when they made this change, when they left the automation system going, that everything was going to work as it was, because we've done this 1,000 times before. We've tested it. We've gone through. We have all these contingencies. We have the error correction built into the code.
Yeah, and I think the interesting point is it actually did what it was supposed to do, right? So the automation system, it worked. It applied the changes. They had a system in place, absolutely. So they weren't making one-off changes, which is something we see in other outages. One-off changes to infrastructure or patch deployed. So they absolutely did the right thing from a process perspective, like Terraform is being used. But then, yeah, like you said, the manual error was that a stale one was actually promoted. So it really, highlights that even if the process is working, there's always variables, unfortunately, that can come into play and create those issues.
It's actually interesting as well then, because you mentioned the process there. They got the process right. They had everything for in there. Part of it as well, if it was actually sort of failing at that moment in time, actually sort of quite hard to be able to sort of understand if their communication methods were sort of built into that. And actually sort of GitLab actually then sort of said what they did. They actually sort of switched into an alternative method. So actually practicing essentially the sort of stuff that we've talked about in previous podcasts of having a backup plan. It might not necessarily be that. Then this was just one on communicating. So they went to Google Docs because their regular mechanisms and internal tools were actually inaccessible.
Yeah, and it's pretty interesting to see because, like you said, that you can't really plan for something like this because you don't really. It's not a normal error condition that the entire infrastructure there is going to get applied to a different state, right? So it's definitely it's interesting to see them use backup tools or backup communication methods. We've seen this in other outages too. Is the need for when you rely on internal tools that have an outage, what do you do? Do you rely on phones or how do you actually communicate it and get it back? So I think it's definitely interesting to see them having a plan in place, like you said. So kudos to them for that.
Absolutely, yeah. It might not have worked as they'd hoped or as perfectly as they thought, but the fact it was there was really important and actually really good to see. These businesses have good visibility, planning process, so they're at a distinct advantage in the outage scenario. As you said, it's if I've got a way to actually, once something goes down, if my normal one's there, we're broke. The example I constantly use around from here is sort of when the financial systems go down or the payment process goes down when I'm in a shop around from there. The attendant doesn't know how to do it. They don't have the old swipe mechanism for the credit card. They don't know how to do the manual process there. And we've seen sort of these outages occur, and people will be able to switch when we actually lose sort of a search functionality, and it impacted when we saw the Google one there when it impacted the search for the maps there. Some logistic companies were able to move to a different mapping system to actually keep things going. So it's identifying the problem. I think you said this earlier. It's identifying where the problem is and being able to sort of take steps around it.
Yeah, definitely. A lot of dependencies as well. I think that's an important part of the planning is dependency mapping. Like you said, we've seen many outages where it's not the main application or it's not even under your control. You depend on an API or you depend on a system. And if that fails, then it causes, an avalanches to a lot of other things. So dependency mapping is definitely a big one.
Absolutely. Absolutely. Well, thanks, Brian. That was really good. Really appreciate it.
My pleasure.
So that's our show. Please like and subscribe. We really appreciate it, and it's valuable to us. As I mentioned at the top, not only does this ensure you're notified as soon as a new episode is available, but it really helps us in shaping the show for you. Follow us on Twitter at ThousandEyes. And any questions, feedback, or guests, please feel free to send us a note at internetreport@thousandeyes.com. So until next time, goodbye.